All right, so this, obviously, this is 6-1, right? So we know this is law of sines, guys. But after today's done, you're going to blend stuff together. 6-1, which is law of sines, is going to get blended in with 6-2, which is law of cosines. Based on the information you're given, you have to figure out which one you have to do. You're only going to be able to do one or the other to start, okay? Eventually, at some point, you could switch, but in the beginning, you're only going to be able to do one or the other. So this is your side angle scenario, which means law of sines, but it also means ambiguous case. So when you start this off, and be really careful because you'll get confident, you'll start working, you'll get an answer, you'll stop. And if there's a second triangle, you've literally missed half the credit on that question. So every time you're given two sides and the non-included angle, you're going to assume there's a second triangle until you prove yourself wrong, right? So from here, the first thing, I know I have my completed ratio in B, so I would say that 10 over the sine of 22 equals the only other thing I know is side A, so 21 over the sine of angle A. And then I'm going to cross multiply, so 21 times the sine of 22, divide it by 10, I get 0.786. If that number, when I divide it, is bigger than 1, I know this is one of those ambiguous cases where there's no triangle, right, like we did yesterday. This one, I know I got to keep going. So second sign your answer. Don't round it, but second sign it. And I get that angle A is 51.875, so 88 degrees. So that's the first thing you're looking for. And we're going to call this A1 because we're going to assume there's a second triangle until we're proven wrong. So angle A2 is found by taking that angle that we just found and subtracting it from 180. So 180 minus 51.88 gives me that angle 2 is 128.12. Now, if you want to see if there's a second triangle, then you're going to take your original angle that's here and this new angle, subtract it from 180. If when you add those two, it's bigger than 180, or you go to subtract, you get a negative number. Now you know there's only one triangle and you're done with the second. But in a case like this, if I want to find the last angle is angle C. If I want to find C2, I'm going to do 180. Again, minus the original, minus what I just found. And this time it's positive. So I know there is a second triangle. 1, 2. Which means I've got one more step on this second triangle. I'm going to finish the first triangle and then come back to it. But I'm going to remember that there's a second triangle. So first triangle, I first found angle A. I still have angle B, which means the last one would be angle C1. And I'm going to do 180 minus the 22 that I was given, minus the 51.88. So 180 minus 22 minus 51.88. And I get angle C1 equals 106.12. Now the last thing I have to find in the first triangle is side C1. So I'm still using the original ratio. I use that for every time I set up law of sines in both triangles because that's the part that was given to me, so I know it's 100% accurate. So 10 over the sine of 22 would equal C1 for my side over the sine of 106.12. Cross multiply 10 times the sine of 106.12 divided by the sine of 22. And I get C1, side C1 is 25.65. And then the last thing I need to find is in triangle 2, side C2. So I still use that same starting ratio because it's true for both triangles. That's what's given. That doesn't change. And then I do C2, but this time I do it over sine of 29.88. Cross multiply 10 sine 29.88 divided by sine of 22. And I get C2 equals 13 point, this would round to 30. So when you go to give me your answer, you're going to see like a big open space. My preference is, first of all, very carefully label these. But if you could label them like in order, like A, B, C, then it would help me grade them. The faster I grade them, the quicker you get your answers back. I mean, your grades back. But I would have my first triangle, which would have angle A1, 51.88, C1, 106.12, and side C1, 25.62, or 65, sorry. And then second triangle, angle A2, 128.12, angle C2, 29.88, and side C2, 13.30, or just 3, because it's going to be an insignificant 0 anyway. Paula.
I got 25.64 for side C1.
Did you use the rounded?
No, I used the...
You did 10, sine of 106.12
yeah.
times sine of 22. And then you did, wait 1 minute, 10 sine of 106.12. Okay, just be careful. There are some, like when we get to law of cosines, you're going to see today, that we're going to be forced to use rounded sides. And when we're forced to use rounded sides, your answers might differ by 100th here or there. But these should be exact because we're using exact values and waiting all the way to the end to round them. Andre.
Why don't we have to get A2, like lowercase a2?
Because it's A is the same for both triangles. Whatever they give you the first carries over.
So we only have to get the stuff that they don't give us any information on.
Correct. For both triangles. Yep. Any other questions? How many of you got it right? Or we're on the right track? How many of you would have known to check for the second triangle had we not hinted towards it? Okay, keep that in mind. So different versions are going to get different cases of ambiguous cases. You might get a none, you might get a 1, you might get a 2. You want to check for the 2. Okay, yeah.
Are you going to give us side angles that have the included angle?
That is law of cosines.
So we have to know for sure.
That it's, yeah. So if you get 1 of every letter, that's law of cosines.
Okay.
Annika.
How can you tell if it's side angle or side angle?
So side, angle, side will be all 3 letters.
All three letters.
But for me, I always double check by drawing it out.
Okay.
Yeah.
So like since it doesn't have
You would get an A, a B, and a C. One of them would be capital.
okay.
Yeah.
Okay.
That's side, angle, side.
Okay. So when it doesn't have every letter, it's ambiguous.
When it's side angle.
If it's 2 sides and an angle.
If it's 2 sides in it.
Yes.
Okay.
Yes.
So when you're drawing it, the side goes across from the angle.
Correct. And in this case, the included angle should be C. So if I gave you C, right, if I gave you B and A, and then I gave you angle C, that side, angle, side. That would be law of cosines.
Oh, okay. So
Yep.
you don't know how to solve that.
Not yet. Mm-mm. Questions before we learn how to? Okay. So, law of cosines, we kind of just went through that first slide, right? These were the formulas you have to know for law of cosines. The first grouping is when you're given side, angle, side. So this is if I'm given 2 sides in the included angle. Again, notice that there's all 3 letters there. I need a side B, a side C, and then the angle A. Or I need a side A, side C, angle B. Or I need a side A, side B, angle C. Those all 3 letters will be represented in these. 2 are sides, 1 is an angle. And then the alternate form is if you have all 3 sides. So there's no angle information given on those. A squared equals B squared plus C squared minus 2BC cosine A. My advice to you yesterday was when you get your quiz, if you want to write down your formulas, feel free, but I don't think you should have to write down all 6 of these. If you want to write down 1 of each, that's fine, because then you should remember where your letters go and where they move. However, if you spend the time on writing them all out, obviously that's losing time on your quiz, okay? All right, so the first was side, angle, side. If I'm given 2 sides in the included angle, which would be 1 of every letter, then the first thing you're going to do is find the missing side using law of sines. So whichever letter, lowercase letter is missing, that's what you're going to find first. Then number 2 says, and this is where it's important, if the angle given is obtuse, which Paula, this was your question, right? If the angle given is obtuse, after you find that side, you can switch to law of sines because you'll have 1 complete ratio. If it's not obtuse, you have to stick to law of cosines. There is no such thing as 2 triangles when it comes to side, angle, side. It's not possible. You can only make 1. But what happens is if you get an acute angle given to the first time, it is possible to create a false second triangle. It would be wrong. So you got to be really careful. To be safe, stick to law of cosines the whole time. But if you want to switch to law of sines, you can only do so if the angle that's given is obtuse, okay? If it's acute, you want to continue with law of cosines. And then obviously when you get to your third angle, you can do the same thing we always do, which is subtract them from 180.
So the only one that can have the second triangle is side setting.
Is that can have like a legit second one. Yes. So, and think about why that's true. Like if you, did we do this yesterday? Do you guys remember how to prove two triangles are congruent? See if you can do this. See if I period can be better than A and C.
Oh, side angle is the only one that you couldn't prove.
That you couldn't prove, right? So to prove two triangles are congruent, how there's 5 ways? Give me one. Come on, you can do it. Geometry, so very long ago. Side is one of them. Side angle side is one of them.
Three angles.
No, 3 angles is not one. Yeah.
Side.
Nope.
Angle, side.
Angle side.
HL.
Hypotenuse leg. Nice. That's the one everybody forgets about. There's one more. You can do it. So these are ways to prove triangles are congruent. Meaning, if I gave every single person in this room 3 strips of string that were the same size as everybody else, not necessarily the same, like all the same size, you could only make one triangle with that information. If I gave you a side that was 3, a 4, and a 5, there's only one way to form a triangle with that, right? If I gave you 2 sides and the included angle, there's only one triangle that can be formed that way. If I gave you 2 angles and the non-included side, only one triangle. If I gave you a hypotenuse and a leg, only one triangle. Angle, side angle, only one triangle. But we could not use side angle because you can make more than one triangle with it, which is the ambiguous case. You can technically take the same measurements of 2 sides and non-included angle, and you can make 2 completely different triangles with it. Does that make sense? So the ones on the left, the stuff that we give you, that's why there's no such thing as an ambiguous case with that stuff. The one on the right, that's why there is an ambiguous case. Okay? So good news, I'm not testing you on how to prove triangles are congruent. But that is why these things happen. All right, so this one says, use the law of cosines to solve the triangle round to 2 decimal places. I have one of every letter. This is my side angle side. If you don't see it, draw it out. A, B, C, angle A is 39. Side B is 21. Side C is 42. That's the angle in between the 2 sides. Side angle side. So the first thing I'm going to do is find the missing side, which is A. A squared equals the other 2 sides, so B squared plus C squared, minus 2 times those sides, times cosine of the angle that matches the letter we're finding. So I get A squared equals 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of angle A, which is 39 degrees. So then I can type that whole thing in the calculator. Smart enough that order of operations holds true. So 21 squared plus 42 squared minus 2 times 21 times 42 times the cosine of 39. I don't have to worry about any kind of parentheses there. And I get that A squared equals 834.114524. How do I get to A? Square root it, which means you could have even done that at the beginning. I could have said the square root of all that stuff, and I can do it all in one step. 28.88. So there's my third side.
You have to continue using law of cosines.
Why?
Because it's not obtuse.
Good. So the angle I gave you was not obtuse, which means I cannot now switch to law of sines, even though I have a complete ratio, right? I have both A's. But you can't switch unless the original angle is given to you as obtuse. So that means I'm going to use law of cosines for an angle. So let's say I do cosine of B. That's the other 2 letters first. So A squared plus C squared minus B squared over 2AC. So the cosine of B equals A, which is 28.88 squared plus C, 42 squared, minus 21 squared over 2 times A times C. Now this is where you have to be so careful in your calculator use. You can say cosine -1, because we're going to eventually do that at the end. Open the parentheses, or opens it for you. But then you have to put parentheses around the numerator and the denominator. Otherwise, order of operations says square all those numbers, but then the first thing it says to do, moving left to right, would be the 21 squared divided by 2. You're going to get a number bigger than 1, you're going to get an error. It's wrong. You have to group them. So you have to group your numerator and you have to group your denominator. If you don't, you're going to get an error, you're going to get frustrated, and I'm going to in my head be thinking, I told you so, and you don't listen to me, because you have to group your numerator and your denominator. Even if you just do this part first and then do cosine -1, you'll still get the error if you don't group it. So I do cosine -1, open the parentheses, so it should be double parentheses now. 28.88 squared plus 42 squared minus 21 squared, close the parentheses, divided by, open the parentheses, 2 times 28, or 28.88 times 42. So angle B is 27.23 degrees. Yep, so for the last one, I can say angle C equals 180 minus the one that was given, that 39, minus 27.23. If by chance you end up with extra time on your quiz, then my advice is to do law of cosines on that C and make sure you get the same answer. It might not be exact because, again, we round when we do law of cosines, but it should be pretty darn close. Gislin. All right, so second type of problem that we're going to use law of cosines for is side, side, side. Obviously, you can't use law of sines. There's no angle to use, okay? The biggest, most important thing with these is that you start with the largest angle. So you start with the one that's opposite the largest side. And that eliminates any possibility of inventing a second wrong triangle, okay? So again, you start with the longest side first. Sometimes it totally will not matter, and sometimes it will give you a second false triangle that looks good the whole time, and it's wrong. So you start with the longest. Once you get that, you can choose whether you switch to law of cosines or you keep to law of cosines or you switch to law of sines. It doesn't matter because you've already found the largest one. And then you'll find the third angle by subtracting the first two from 180. And they look like this. Use the law of cosines to solve the triangle round to 2 decimal places. If you're like a picture drawer, feel free, but honestly, I never draw the picture on side, side, side. It's an extra waste of time. You don't need to, okay? Because you know what you're given. You're given all 3 sides. So which one am I going to start with? Angle C, right? Because of the 20. So I'm going to say the cosine of angle C is equal to the other 2 letters. So A squared plus B squared minus that letter over 2 times the first 2 letters. Because it's the biggest angle. You've got to start with it. Because you're trying to find that obtuse angle is what's happening here. And then that way you're starting it off right.
The biggest angle we choose, like,
Which is opposite the longest side.
Okay.
Yep. So then cosine C equals 11 squared plus 14 squared minus 20 squared over 2 times 11 times 14. So I'm going to do cosine -1. I'm going to carefully open the parentheses, 11 squared plus 14 squared minus 20 squared. And then I'm going to close those parentheses, divided by, open the parentheses, 2 times 11 times 14. And you get 105.633. That first one may not always be obtuse, but obviously if you do it the right order, it's always going to be the biggest. Okay, so like we said before, now I can switch and use law of sines if I want to. What would be the benefit to keeping with law of cosines?
It'd be guaranteed, but like you can in this case because the angle's obtuse. To use
Right.
law of sines.
So you can switch because we found the biggest angle, which is obtuse, right? But so I can switch to law of sines. But one, what if I found the wrong angle? I'm using the wrong angle. That's case scenario one. That would be negative. Two, I'm making it less exact because we just rounded that angle, right? If I stick to law of cosines, I'm keeping with exact values from the beginning. Okay. So if that's the case, then I would say the cosine of A equals, and I would do the other two letters, b squared plus c squared minus a squared over 2bc. So 14 squared plus 20 squared minus 11 squared over 2, 14, 20. And then I'm going to do cosine -1 of the whole thing, grouping the numerator and the denominator.
Why do we do one? Why do we do 8?
It didn't matter.
Didn't matter.
After you do C, it doesn't matter which one you pick. After you do the biggest, it doesn't matter the order. 31.98 degrees. And again, with extra time, you can check it with law of sines. It may not be exactly the same because we'll have to round for law of sines, but it should be pretty darn close. And then my last angle is angle B, which is 180 minus 105.63 minus 31.98, or it can be done law of cosines to again check your answers. Just don't waste all that time until you get to the end and know you have extra time. So again, in your like answer section on your quiz, if you could list them alphabetically, it makes it easier for me, okay? But you would list those 3 angles. Okay, so then you've got some, this one is sort of even, it has words, but it's still just like a diagram. It says find the angle theta between the 2 bases for both the carnivore and the herbivore. So these are like footprints of 2 animals, and you're looking for the angle in between them. So if I look at the one on the left, I've got side, side, side. The one on the right, I also have side, side, side. They conveniently are asking you to find the obtuse angle, so it does it in the order you need to. Anyways, if it had asked you for any other angle, as long as you do law of cosines, it's fine. But if you switch, that's when it's the problem. So I would say for the first one, the cosine of theta for the carnivore would be the opposite. So it's these 2 letters minus the opposite side. So if you want to give it letters, you can. If this was A, this would be A, this is B, this would be B, this is C, this would be C. So I'm technically finding the cosine of A, which would be B squared plus C squared minus A squared over 2BC. So 2.5 squared plus 3.0 squared minus 5.78 squared over 2.9. I don't need the 0.0 for the 3. I can just leave the 3. And then I will second cosine that. So second cosine, open the parentheses, 2.9 squared plus 3 squared minus 5.78 squared divided by 2 times 2.9 times 3. And I get 156.85. And then I do the same thing for the other. It's the cosine of theta, the 2 adjacent ones. So 3.6 squared plus 3.2 squared minus the opposite one, 5.2 squared over 2 times 3.6 times 3.2. Second cosine, open the parentheses, 3.6 squared plus 3.2 squared minus 5.2 squared divided by 2 times 3.6 times 3.2. 99.59. Questions on that one? So it does have. Oh, you know what? Don't worry about these. I'm not going to ask you for. Wait. Let me give you that values. So it says if you're on island B, what bearing should you navigate to go to island C? Let's do that one. If you're on island B, don't worry about the second one. So we'll do the first one. So let's say this is 10, this is 12, this is 8. We'll just make up stuff.
We have 22.
Oh, you have stuff? Look at, sometimes I'm smarter than I think I am. What do you have? 16, 22, 23. And you already had the second part crossed off, didn't you? Yeah, okay. All right, so what about a bearing is important? What's the difference between a bearing and an angle? I need direction, right? So I need to know, is it north-south on the first part? I need to know, is it east-west on the second part? So before you even get to a value, how would I get from island B to island C? I'd have to go up and left, which is what? North and west. Now I just got to figure out what this angle is here. How could I do that?
Why don't you just go straight?
You could go straight, but that's a bearing. You'd have to know to go northwest that straight, right?
Okay.
And you're in a pretend environment in which you're being forced to do a bearing. So how do I figure out that what that angle is on the outside?
You have to figure out angle B.
Good. I got to figure out the angle on the inside and then good. Complement or subtract it from 90 degrees. So the first thing I'm going to do is find angle B. I'm going to say cosine of B equals, and it would be 22 squared plus 23 squared minus 16 squared over 2 times 22 times 23. And I would say second cosine, open the parentheses, 22 squared plus 23 squared minus 16 squared, close the parentheses, divided by 2 times 22 times 23. And I get 41.58. So that's what's happening in here. So to find the other part, minus that, or subtract that from 90 degrees, and I get 48.42 degrees. So the bearing has to have the north and the west part, okay? North 48.42 degrees west. Patricia. Because I need this angle that's here. So the only way to get there is to find this one and then subtract it from 180. I mean, subtract it from 90.
How did you get 48.42?
Subtract 41.58 from 90. Yeah, because the 41.58 is the purple part. That's on the outside of the triangle. No, I mean, that's the black part. That's on the inside. We need the purple part. That's on the outside. Questions? Yep.
So in this case, if you solved for like 23 first and you got an angle that wasn't obtuse, but it was like the biggest side and you got that angle, could you still use law of sines, or would it still be better to just use law of cosines?
If it's the biggest side, but no. That's where you can get a second. So you want to make sure the only way you can switch is if it starts obtuse.
Okay.
That's the only way you can switch. Otherwise, you have to stick to law of cosines. And it's not even like I wish I could teach you a trick to like figure out when that scenario happens. It's not. It's totally obscure. Okay, last thing they're gonna learn before your quiz, and it's super easy, is the area. How do you find the area of a triangle when you only know the side lengths? So this is called the Heron's area formula. It actually has a name, the other one doesn't. And it is found with only the side lengths. So you do S, which you have to figure out what S is first. The square root of S times S minus A times S minus B times S minus C. And you find S by doing A plus B plus C divided by 2. Not the average, because then you divide by 3, but by 2. Biggest thing is here is that you can not round S. It might have 3 decimals. I think the furthest goes 4. It will eventually stop. But you cannot round it. Every year somebody does it, even though I'll say it for the next 2 days straight. Do not round it. It'll look like this. Find the area of the triangle with the given side lengths. Again, you get all 3 sides there first. So the first thing you're going to do is find S. So S is 5 plus 7 plus 10 over 2. In this case, this should be easy. 12, right? Plus 10, 22 over 2. And I get a nice round number. Step our way in. So then area is the square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. You could simplify that, or you could write it in exactly as it is in your calculator, okay? Honestly, this thing is like more annoying because when you get to like something like B where it's a little bit longer of an S, it takes more time to type this in the calculator than it would be. at most problems.
I just copy it.
Say that again?
You can copy it on my calculator.
Yeah, but you still have to like subtract all the other parts. Does that make sense? Like you still have to plug all that in. This, not so much, because you could do that in your head, right? But for the other, you'll see in a second what I talk about. So 11 minus 5, 11 minus 7, 11 minus 10. Or you could have figured all those out and done 11 times 6 times 4 times 1. Okay, you could have worked it all out, but you have your calculator, so might as well use it. A equals 16, I think it says 2 points. 2 rounded to the nearest hundredth on your quiz, so you keep it that way. And this would be unit squared.
Don't put units squared or wrong.
No.
Is it wrong on the other?
Okay, last one. So I have to do 3.05 plus 0.75 plus 2.45 and divide it by 2. So 3.05, 0.75 plus 2.45, that's 6.25 divided by 2. And I get S equals 3.125. Are we going to round that?
No.
No. So I get the square root of 3.125 times 3.125 minus 3.05. 3.125 minus 0.75. 3.125 minus 2.45. And I get 0.61297. So 0.61. And again, it doesn't give me a unit, so it's unit squared. Is it possible for the area to be smaller than the side length? Sure. Right? Especially with decimals. When you've got something less than 1 and then cut it in half and multiply it, it's making it even smaller. So don't be alarmed if it's small. Obviously, if all those numbers were big, then you would be concerned. But that 0.75 throws us off. Questions on anything law of cosines related? All right, I'm going to tell you right now that the 2 biggest mistakes people make on this quiz is not putting that law of cosines in the parentheses and then getting an error and then getting all upset. Second is rounding S. Don't do either of those things, okay? Because you're going to like call me over your desk and be like, it's giving me an error. And I'm going to look you in the face and try to will you to remember that I'm telling you not to do that. Or you're going to round the S and you're going to get points off. Don't do that, okay? Be smart. Okay, this is one of the questions that's on your homework. Obviously, your values are going to change, but it's based on a parallelogram, so you got to know properties of parallelograms. What do you know about the diagonals of a parallelogram? Do you remember? They bisect each other. So when they give you these values, first of all, the C is the whole diagonal there, and the B is this, or the D is this whole diagonal there. But they do bisect each other, which means this is congruent to this and to that. So you can basically take yourself and make yourself 2 smaller triangles using the top one and the bottom one. This way, where you've got this angle, this side, and this side, that's law of cosines, right? Gets you the full gray sort of hypotenuse. It's not the necessarily a right triangle, but that's that. And then you can use a triangle this way, because these are congruent, okay? Or you can use a triangle this way with this angle, this side, and these are congruent. So properties of parallelograms are opposite sides are the same, opposite angles are the same, diagonals bisect each other. What else am I missing? Consecutive angles are supplementary. All that stuff could come back into word problems and that kind of stuff. So make sure you know all that stuff. Does that make sense? So Annika, like if you split it in those 2?
Yeah.
Okay.
I was starting